Hey there, everyone! Welcome back to our channel. If you're passionate about deep learning or just curious about how artificial intelligence works, you're in the right place. Today, we're diving into an essential concept in the world of neural networks, batch normalization. We'll explore what it is, why it matters, and how it can significantly improve your machine learning models. So, grab a snack, get comfy, and let's get started. Now, before we roll into the nitty-gritty, let me ask you this. Have you ever trained a neural network and felt frustrated with how slow or unstable the training process was? If so, you're definitely not alone. This brings us to the idea of batch normalization. So, what exactly is batch normalization, and how does it tackle these issues? Let's find out. Batch normalization, often abbreviated as BN, is a technique used to improve the training of deep neural networks. It was introduced by Sergey Ioffe and Christian Szegedy in a paper titled Batch Normalization: Accelerating Deep Network Training by Reducing Internal Covariate Shift in 2015. But what does that mean? To understand batch normalization, we first need to grasp the concept of internal covariate shift. When training a neural network, the distribution of each layer's inputs changes during training as the parameters of the previous layers change. This shift can slow down the training process. Imagine trying to balance a tightrope while the rope is constantly moving beneath your feet. It's tough. Batch normalization helps stabilize these changing distributions, making training faster and more reliable. So, how does batch normalization work? The process involves normalizing the inputs of each layer. Here's a step-by-step breakdown. 1. Calculate the mean and variance. For each mini-batch of data, we compute the mean and variance of the layer's inputs. 2. Normalize the inputs. Next, we subtract the mean and divide by the standard deviation, which gives us a normalized output. This step ensures that the inputs to the next layer have a mean of 0 and a variance of 1. 3. Scale and shift. Finally, we introduce two parameters, gamma and beta, which allow the model to learn the optimal scale and shift for the normalized output. This flexibility is crucial because, even though we want to normalize the data, we don't want to lose the ability to model complex relationships. Let's visualize this with an example. Imagine you're training a deep neural network to classify images of cats and dogs. Without batch normalization, your model might struggle with inconsistencies in the data, leading to long training times and potentially poor performance. By applying batch normalization, each layer receives inputs that are standardized, which helps the model learn more effectively. Let's look at some data to illustrate this point. In a 2015 study, researchers found that using batch normalization reduced the number of epochs needed to reach a certain accuracy in a convolutional neural network from around 50 epochs down to just 20. That's a significant improvement, and it demonstrates how batch normalization can accelerate the training process. Now, you might be wondering, is batch normalization only useful during training? Not at all. During inference, we use the learn parameters to ensure that the model still performs well on new, unseen data. This consistency is crucial for deploying reliable models in real-world applications. But batch normalization isn't a one-size-fits-all solution. It's essential to consider when and how to apply it. For instance, it can sometimes interfere with certain types of architectures, like recurrent neural networks, where the sequential nature of the data might not fit well with the batch normalization process. In such cases, alternatives like layer normalization or instance normalization may be more appropriate. Another point to consider is that while batch normalization can help with training stability and speed, it may introduce additional computational overhead due to the extra calculations involved in normalizing the data. However, most of the time, the benefits outweigh the costs. So, in summary, batch normalization is a powerful technique that helps stabilize and accelerate the training of deep neural networks by normalizing the inputs of each layer. It tackles the problem of internal covariate shift, making the training process smoother and more efficient. By incorporating batch normalization, you can improve model performance and reduce training time significantly. Alright, folks! That wraps up our deep dive into batch normalization. We've learned what it is, how it works, and why it's so important in the world of machine learning. If you found this video helpful, don't forget to give it a thumbs up and share it with your fellow aspiring data scientists. And remember, the journey of learning is ongoing. If you have any questions about batch normalization or suggestions for future topics, drop them in the comments below. We love hearing from you. Until next time, keep exploring, keep learning, and stay curious. Bye for now.